All right, so then for number 6, it wants you to draw a line to the equivalent function. So we have x minus 6 and x plus 4. So obviously here we would FOIL. So I'd have x times x, which would be x squared. I would have x times 4, which would be 4x, and then negative 6 times x, which would be negative 6x. So 4 minus 6 would be negative 2x. And then negative 6 times 4 would be negative 24. So this one would go to the top one. Okay, then the second one, I have x minus 5 squared. So remember, anytime you see anything squared and it wants you to simplify, then you're going to have to write it twice. So x minus 5 times x minus 5. And then we still have that minus 49. So we would, again, FOIL here. So x times x, x squared. X times negative 5 and x times negative 5 would be minus 5 minus 5. So that would give me negative 10x. And then I've got minus 5 times negative 5, which would give me positive 25. And then I still have that minus 49. So then I can combine like terms here of that plus 25 minus 49. So 25 minus 49 is negative 24. So then I still have that negative 10x and that x squared. So this one doesn't look like any of the ones that I have. But if you look at your answer options, and then you look at which ones make sense, okay, positive 12 times positive 2 isn't going to give me a negative 24. Okay, this answer choice doesn't have the middle part. This one doesn't have a minus 24. Or it might end up to negative 24, but let's look at this one. I have negative 12 negative 12 times positive 2, which is negative 24. And then if I add them, I would have negative 12 plus 2, which would be negative 10. So this one is going to be my answer. Okay, because my factors are going to add up to get what I need. Okay, so then I have this last one, which I'm not going to have room to do over here, so I'm going to do it over here. I have x squared plus 2x minus 24. Okay, so I have to look at the answer choices that I'm given. Okay, here, again, I'm looking for something that multiplies to negative 24. For B, I have positive 12 and positive 2, so that's going to be a positive 24, so it's not going to be this one. Okay. Again, here, it's not going to be C, right, because it doesn't have a middle part, so that doesn't make sense. So it has to be this one, but let's find out how it's that one. So how we get from point A to point B is by completing the square. Okay, so the way that we do that is, first of all, we group our first two terms together, and we put our last term on the complete opposite side. So we're going to say x squared plus 2x, put a blank here, equals, since it's negative 24, when it moves to the other side, it becomes positive 24, and then we leave another blank. So here is where we would take that 2, we would divide it by 2, and that equals 1, and then we square it. So remember, we always divide by 2 and square. So then 1 squared is actually 1. So then we're going to add 1 in both of these blanks. So then we're going to say x plus 1. Remember, it's always the number inside those parentheses. Squared equals 24 plus 1 is 25. Okay, and now we've completed the square. We just need to move this 25 back over to the other side. So x plus 1 squared, and when it moves to the other side, it becomes negative. And then y equals. So that is how we got our answer. So then number 7. Number 7 is the video that we talked about right before spring break of logarithms. Okay, we talked about the properties. So anytime the 2 is in front, that means that it's going to be the power. So that means it's going to be log base 3 of x squared plus log base 3 of y cubed minus log base 3 of z to the 5th. Okay, again, properties, when I add, same as whenever we talked about exponential properties, adding always means you multiply. So that means I'm going to say log base 3 of x squared times, which I'm not going to put anything there because if you just put x squared y cubed, that means you're multiplying. And whenever you subtract, you divide, just like with exponential. So when I divide by z to the 5th, you don't have to write that log of 3 because as long as they have the same base, then you're good. So that is answer choice A, I believe. Yes, A. So then number 8. We've had one like this on a similar practice test. The way that we would solve this one is we would just have to factor each individual part and then cancel out what we cancel out and then see what we have left. So looking at this very top part, x squared minus 1, that's a difference of squares. So we've got x squared minus 1 would factor to x plus 1 and x minus 1. Okay, then if we look at the next, or the part on bottom, I have x squared plus 2x plus 1. That's a trinomial in which a is 1, so that would be where I just draw my x. I'd put 1 on top and a 2 on bottom. What's going to multiply to 1 and add to 2? And we know that that's 1 and 1. So that's going to be x plus 1 and x plus 1. Now, next, I'm going to take it back to like 3rd grade. And since I'm dividing by a fraction, then I know that I'm going to multiply, and I have to flip that fraction upside down. So I'm actually going to put this 1 minus x on the bottom. Okay, anytime you divide by fraction, you have to actually multiply and flip that fraction upside down. So that might need we might need to remember that from a long time ago. So that means I'm going to put that x plus 1 on top. Okay, so now I just need to cancel out what cancels out. So I've got, let's see, an x plus 1 here and an x plus 1 here. I've got an x plus 1 here and an x plus 1 here. As long as you have 1 on top and 1 on bottom, they cancel out. Okay, so then that leaves me with x minus 1 and 1 minus x. But if I look at 1 minus x, I can actually rearrange that to negative x plus 1. And then if I take out that negative, if I factor out that negative, it would be negative x minus 1. And then I have x minus 1 on top. So then if I have an x minus 1 on top and an x minus 1 on bottom, then they cancel. So then I just have a negative. And then we know that there's understood to be a 1. So my answer is actually just going to be negative 1. Everything actually cancels out except for 1 negative. Okay? So try it. Sometimes it just takes some manipulating. You've got to make things the way that you want them to be. All right, number 9. So it wants to know what reflections happen or what transformations happen where. So reflection across the x-axis, we know a reflection happens when there is a negative in front. The next one wants to know when there is a translation h units to the left. We know that left means that the h is going to be a positive number, right? Because that's opposite of what we normally think. We would think that going to the left would make it negative, but h is always going to be opposite, so that means it's going to be positive. So your h is going to be positive, just like right there. Okay. The next one says a translation of k units up. The k is actually what we think it is, so k is going to be positive. So over here, k is negative, here k is positive, so it's going to be this one. And then a vertical dilation. Dilation is the same thing as a stretch or a shrink, okay? So since there is an a here and there's not an a anywhere else, it's going to be this one. It's going to be j of x. Okay, number 10. Let's switch the colors. 10 is rational expressions. We just got done talking about this. 25 to the 1/2 is the same thing. Remember, the bottom number goes to the index, and then you've got 25 to the 1. So that'd be the same thing as the square root of 25, which we know is 5. And then we've got 4 to the x to the 2/3. Remember, if there's not parentheses around the whole thing, that the 2/3 just goes to the x. So this one's actually going to be 4 is going to be on the outside. And then the square root, the 3 is going to be your index. And then you've got x squared. So that one is going to be down here. And then last but not least, you've got x to the 1/3. Again, the bottom number is your index. So that would be the top one. All right. So number 11. This is something that we've not really talked about before, okay? So we have talked about similar things, though. So we know that this is a cubic function, right? But it looks a little bit differently, okay? We know that these are the factors, okay? So we've talked about multiplicity before, and what multiplicity is if it has an even multiplicity, then that's going to bounce off, right? So if this number right here is an even number, then it's going to bounce and reflect off. If this number right here is an odd number, such as right there, then it's going to just cross. Okay, we talked about that a couple months ago. So whenever I say x minus 2 equals 0, then that means that x would equal 2. Okay, so that would mean that it would have to cross right here, which that one doesn't. So that means that A is not our answer. Okay, again, that would mean that B is not our answer. So it'd have to be C or D. Okay, now the thing that we need to know here is it positive or is it negative? Because that's the only difference in C and D. Now, a normal cubic function looks like this. And you can know that just by typing it in your calculator, okay? Or by now you should probably know what a regular cubic function looks like. So this one is actually opposite of that. So that means that this one is negative of that. Okay? So since it has a multiplicity of 2, where x plus 2 equals 0, at negative 2, that means that it's going to bounce back. It's not going to cross over it too. It's going to just reflect off of it.